Hello, good day viewers. Let us find a solution to this simple logarithmic inequality, which is the log of x minus 1 with the base of 0.3 greater or equal to log of x minus 1 with the base of 0.09. Alright, let's get started. We're going to start with domain. Remember, the argument must be greater than 0, which means x minus 1 will have to be greater than 0. If this is the case, you definitely know that x must be greater than 1. So this is the first condition. And secondly, you should know that 0.09 is the same thing as 0.3 whole squared. So let us rewrite it. We have log of x minus 1 with the base of 0.3. This is greater or equal to log of x minus 1 with the base of 0.3 whole squared. I remember another law of logarithm which stated that if you have log of a with the base of maybe b to the power of c, this is the same thing as 1 divided by c multiplied by log of a with the base of b. All right, for which our c here is 2, right? So we can transform the right hand side in this form. So the left hand side will remain log of x minus 1 with the base of 0.3. This is greater or equal to 1 divided by 2 multiplied by log of x minus 1 with the base of 0.3. Alright, I would like to take this term to the left hand side. We have log of x minus 1 with the base of 0.3 minus 1 over 2 log of x minus 1 with the base of 0.3. This is greater or equal to 0, right? So just look at it. We have one quantity of log of x minus 1, and we have half quantity of log of x minus 1. So if you take 1, you subtract a half, you're going to get a half, right? So we have half of the whole of log of x minus 1. So we have half of log of x minus 1 with the base of 0.3. This is greater or equal to 0. And we can now multiply both sides by 2 just to clear this fraction. If you do that, you're going to have log of x minus 1 base of 0.3 greater or equal to 0, because 2 times 0 is still 0. So you should remember this. If you have log of, let's say, a with the base of c, if this is greater or equal to, maybe let's call it d, provided that this c is between 0 to 1, that is 0 less than c less than 1. If that c is between 0 to 1, then it implies that a must be less than or equal to c to the power of d. And you can clearly see that this is our c, which is 0.3, is a value between 0 to 1, right? It is less than 1 and greater than 0. Therefore, we can transform this into x minus 1, which is the argument. So the direction of the inequality will change, because you can see that here from greater than to less than type. So we're going to have less than or equal to 0.3 raised to the power of 0, which is to the right hand side. And we know that 0.3 to the power of 0 is 1. So x minus 1 is less than or equal to 1. Now we can take this one to the other side. It becomes positive. 1 plus 1 is 2. So x less than or equal to 2. Well, remember our domain is x greater than what? 1. So on a number line, you can clearly see that if you have 1 here and 2 right here, graphically you can see that we have x less than or equal to 2 here, and we have x greater than 1 here. So our solution is between 1 down to 2, excluding 1 but including 2, right? So we can either write it in an inequality form, which is 1 less than x less than or equal to 2, or you can write it in an interval form, which x belongs to the set of values from 1 down to 2. You see the difference? Excluding 1, including 2. And this is said to be the solution to this problem. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.